So, hello and welcome to this EUFRAS coffee break today. It's very nice that you all joined us. The EUFRAS coffee break is a monthly event, and today we are having an intervention of the project EXCALIBUR. Thank you to you, the three speakers today, for this very interesting topic you offer us. You will take us below the surface. It's about the soil, fertility of soil, and the components that you are delivering research on. So this is going to be very interesting. I'm curious what I will learn. Me, myself, I'm not a plant production specialist, but maybe a lot of you who are listening, you are. So I would like to introduce Stefano Mocali, Loredana Canfora from CREA, and also Maria Grazia Tommasini from Ri.Nova. Thank you that you are covering the EUFRAS coffee break today. It's a short format, 1 hour. All of you found the time to join in your daily work, and we try to keep questions that arise for the end. So we try to keep around 10 minutes for your questions and answers. So take notes. You can also fill the chat. We will follow this together with Ilse and Carolina. We will try to also follow the chat that we have your questions. And okay, then please, Stefano, it's all yours.
Thank you, Pablo. Thank you for the invitation. We are very glad to be here at this EUFRAS coffee break. Thank you for this opportunity. I'm Stefano, as you said, Stefano Mocali from CREA, the main research institution in Italy in agriculture. And we are glad to coordinate the EXCALIBUR project as CREA. Me and Loredana are part of the leading group of this project, which is expected to finish in a few months. So we are approaching the end of the project. We are getting the main results right now. Not all the results are ready, but most of them are already available, and would like to share with you together also with Maria Grazia Tommasini from Ri.Nova, one of the main Italian, how can I say, farmer consultant association, or more than that, I would say. And she is leading one of the working package of the project dealing with the field trials. And so I guess most of the participants today expect to have some concrete information, and that's what we are going to talk about. So just to show you something about what has been our experience in this project, hoping that to stimulate your curiosity and the discussion. So don't hesitate to make questions at the end of this presentation. So I will share my screen. Let me know if you can see it.
Yes, this looks very good.
Okay. So, as I said, this presentation will be introduced by myself, but also the support of Loredana and Maria Grazia Tommasini. And we'll talk about EXCALIBUR, which is an Horizon 2020 project dealing with bioinoculant issue. And so I will introduce the project in this first part of the presentation. I will leave the floor to Maria Grazia Tommasini for the description of the main outcomes coming from the field. And then Loredana will conclude with showing which innovations, the main innovations we got into the project. Of course, I'm not going to describe the details of all the results, how the project is structured, the participants, etc. But you can find all this information in our website. So I will invite you to visit it in case you're curious to get more information. I guess this presentation will be recorded, so the file will be available the EUFRAS website, I think. So you will be able to read, to get all the information, share in this presentation also later. So you don't need to write anything. So let's start with a description of the main goal of this project. So the purpose was to, first of all, to improve our knowledge about soil biodiversity, and with a specific focus on its dynamics in relation to different factors in order to promote and enhance the efficacy of biocontrol and biofertilization practices in horticulture. We did it, we selected three, let's say, model crops: apple, tomato, and strawberry, in order to understand how bioinoculants could be used to promote the plant health and protection under real conditions, and which kind of link and interactions occurred with soil biodiversity, which is the role of soil biodiversity in the application of these products. So first of all, I'm sure most of you are aware of this, what we are talking about. But when I talk about bioinoculants, I want to be sure that you know that these kind of products are mainly represented by a combination of one or more microbial strain, beneficial microorganisms, which are normally present in the environment. Maybe you know that many organisms, microorganisms, could be beneficial in different ways, promoting plant nutrition, unlocking nutrients present in soil for the root absorption. So promoting the access to nutrients that usually are not available, but also fixing nitrogen and protecting roots and plants from pathogens. So we can, in the market, there are several products made, microbial-based products, based on this kind of beneficial organisms that could be grouped in three main categories: biofertilizers, if the product is kind of an alternative to conventional fertilizers; biopesticides, in case these products are made to promote plant protection as protection activity; and biostimulants, which is a more broad category, including a number of products that somehow support plant response to different biotic and abiotic stresses. So this is an overview. Of course, you can get more information, but it's important to know, to let you know what we are talking about. So the main goals of the project were, first of all, to better understand, extend our knowledge about the links occurring between soil biodiversity and the plant nutrition, the application of external fertilizers, inputs, etc. What's going on? So which are the processes that are activated or increased or decreased, etc. So there's a lot of knowledge to be extended, and that was one of the main goals of the project. And we also aim to develop a new approach to produce effective bioinoculants, to help these products to be really effective in the field, thus reducing also the external chemical inputs. The aim was to reduce these inputs of about 10-30%. And we also developed a number of tools aiming to support farmers. So DSS able to support farmers to adopt the best management practice for their own situation, and also diagnostic tools to monitor and optimize the application of this kind of products. All these things will be described in this presentation. So first, before continuing, I'd like to make a quick Mentimeter survey with you. So I ask you to take your mobile phones, or maybe directly with your computer or laptop, and connect with this Mentimeter link, and use this code in order to start the survey. You should be able to see the first question, I guess. Let me know. First question is really easy, just to know more or less where are you from. So it's not that difficult. We are about how many? 27 participants. So yeah, a little bit less than expected, but it's important to us to have an idea of the geographical distribution of the audience. Okay, I think 13 people already voted. Okay, let's wait maybe a few seconds more. And then we could move to the next question. Okay, I would say that Germany is the winner. So Lithuania, also Latvia are significantly present. Okay, so we have almost 20 voted. So I'd say to move to the next question. Okay.
Stefano, sorry.
Yeah. Yes.
We are not seeing the results. We are just seeing the slides. Is that so?
Okay. Okay. So
I don't know if you want
sorry.
to.
Sorry. Yes, I will show. Thank you for.
Thank you.
I will fix this. 1 second. Can you see now? No.
Yes, we can see it.
Yeah. Now
Okay.
you can click on present on the top. Yeah. Oh, yeah. On the top right, you have the bottom present. If you...
Which button? Sorry.
Maybe it's
Present.
yeah.
No, okay, good.
Yeah, now it's perfect.
Okay, great. Thank you very much. I couldn't see. Okay, so now, okay, you should be able to see the second question, right? Okay, which is about your level of knowledge about these kind of products. So, are you familiar with these products? You're an expert, or never heard about this. So, in order to also to better understand which are your expectations and which kind of language and to okay. So I think that the unique winner category. So most of you have a limited knowledge of these kind of products, and that's good for us. Anyway, in any case, it would have been good, but it's important to know that maybe most of you have a lot of curiosity about what this kind of products could potentially do, etc. Okay, so I think with 20 people, yeah, about the average number of voters already voted. So let's go to the third question. Okay, so this is not a tricky question, but it's about your feelings. So based on your knowledge about bioinoculants, would you recommend to apply these products, or maybe not? Yes, for sure. Why not? Or I don't know. So I'm etc. So okay, yeah. See, no negative question and answers, and that's interesting. And most of the participants recommended the application, but also some of you is not completely sure about their adoption. Okay, interesting results. So thank you very much for your active contribution. Let's wait maybe a few seconds more and just to leave people to yeah, we got 16 votes. Maybe we can reach 20. Okay, but if not, we could move quickly to the last question. No more votes. Okay, great. Thank you for voting to this question. And this is maybe the most tricky question. So I'm asking you to rank the main factors that you think that may potentially limit the application. Which is the main issue? So could you please prioritize which, in your opinion, are the factors that could or actually limit the adoption of these kind of products in agriculture? So maybe these products are too expensive, in your opinion, or maybe the efficacy is not that sure, so somehow limited, or maybe they could be harmful or dangerous for human health, or you think that maybe they're affecting for the environment are not that very well known, or maybe it is because of uncertain regulatory framework, so it's not very clear how these products could be registered, put into the market, or adopted in the field, and so on. Or maybe it's a matter of, insufficient information about these products. Okay, so these preliminary results indicate that the priority, in your opinion, is given to the low information available for these products, and also their uncertain efficacy or their expensive costs could be relevant items. But the less prior, the less relevant point regards their potential harm damages for human health. So I think that's good. We feel quite safe. I mean, this kind of process shouldn't be that dangerous. Okay, so I think that the trend is pretty clear. So, and I perfectly understand. With the colleagues of EXCALIBUR, we could absolutely agree with this feeling, with these results. The insufficient information regarding these products and their actual heterogenic efficacy under real conditions in the field were the starting point for the preparation of the EXCALIBUR proposal. So I hope that we will give you some insight about this. Okay, I would like to thank you for your participation. I would keep on moving with the presentation. Thank you so much. Let's go back. to okay this presentation. Can you see it again? Okay.
Yeah.
So thank you for this contribution. I would say that these products, despite their limitation or potential limitations, they are really interesting, and the application of these products represent a real promising option to reduce chemical inputs in agriculture and to promote sustainable agriculture in general, in terms of biofertilization, but also for bioprotection purposes. And the market responds very, very well. These are projections of the expected market for the next years. As you can see, is a growing market. So a lot of expectations is about on these products, but their efficacy in the field is really still heterogeneous for a number of reasons. So what we did in this project was, okay, let's try to figure out which are the main key drivers and critical points for the application of these products. And so we started from a real condition, from the engaging farmers, hosting trials and cropping systems with real stress conditions, biotic or abiotic conditions with a real problem. And depending on the kind of stress, we selected a number of available microbial strains, which were already known to be effective against specific stress source. And these microbial strains were used by the industrial partners in combination with biofactors and improving the fermentation and formulation processes. And they provided and developed a number of new multifunctional products. Most of them, part of them were tested under field conditions during 3 years. So we monitor the agronomical performance of the crops treated with these products, and also focusing on the dynamics of the soil biodiversity. So what's going on around below the topsoil. So all this research activity provided a lot of information. So of course, new knowledge, very useful for the industrial partners to keep on improving the formulation and the fermentation processes for the preparation of these products, but also new tools and practices useful for supporting the daily farmers' activity in order to better decide which is the best management approach or product to be used for their own situation. So this is what we did, and basically we adopted a not standard approach, just to select beneficial strain, make it grown in the lab and formulated in as a liquid or solid substrate. But no, we adopted a prebiotic and probiotic approach using some compounds that are able to stimulate the autochthonous soil biodiversity, which represent a huge amount of unknown biodiversity with a huge potential. But this process could stimulate beneficial processes for plant health, growth, and protection. And in combination with probiotics, so a direct inoculation of single or multiple microbial product in combination to lab scale first, and then we selected the best products under control conditions on tomato, strawberry, and apple, of course. And then the most successful products were tested under field conditions in order to improve and take the TRL level higher with the support of the industrial partners. So I'm going to leave the floor to Maria Grazia in order to let you better understand what we did, what we observed in the field, and I thank you for attention. Maria Grazia, the floor is yours.
Good morning to everybody, and thank you to be here with you this morning. I will try to tell you some about part of the activity carried out during the projects, and in particular related to what we have seen in the field activities that we implemented along the 3 years applying binoculants. In particular, we wanted to see the effect of these binoculants related to the agronomical performance in real field condition. And in this case, we worked in both conventional and organic systems on the 3 crops systems that Stefano already mentioned before. In particular, on the 14 kind of byproducts that were analyzed in the laboratory and suppliers of these byproducts, we selected, have been selected 16 of them to be applied in field condition. In particular, these were belonging 3 different kind of microbials or non-microbials, so biostimulants, as you can see in these slides. In particular, 11 were fungi that are listed here in part. 1 was a bacteria, and 5 were biostimulants, so of different origin. Can you please go on, Stefano? In this slide, you can see a very, very quick overview of the 32 trials that have been carried out in 8 countries on the 3 crops. In particular, 14 of these 32 trials were developed, implemented, looking to the biofertilizer effect that this kind of binocular could achieve. 18 of them were observed for their biocontrol effect on some main disease, soil-borne disease problems. Besides the use of binoculants, also some biostimulants, as I mentioned before, were applied, sometimes together with microbials or alone. And according to the kind of let's say, effect they could have on the plants, they were applied on soil or on leaf or on both. You can see here in the table where the different trials on the 3 different crops were applied, and we tried to harmonize the distribution of the different trials in the different pedoclimatic conditions, so that we identified as a country on the 2 different agricultural systems, so integrated agriculture or organic agriculture. Please go on. This is more or less the process we followed. Starting from the selections, of course, of the field in which to apply the different bioinoculants, and making, of course, a baseline of the different information starting from those of soil. We then started with the experimentation, applying the bio-based products. We decided to make only 1 application to have a common basing approach. And we will see later that maybe a multiplied application could be useful to understand some more effects in future activities. But apart from to analyze the effect of this application on the plant, analyzing agronomical, physiological parameters on the plants, but also the plant health, so the effect on the disease control that could be evaluated according to the application of the bioinoculants. The field trials were also the, let's say, arena by which a lot of additional analyses have been carried out related to what was happening into the soil. And for this effect, a lot of activities and analyses have been carried out related to the physicochemical analysis, biochemical analysis, DNA-based analysis, mycorrhization of the roots, analysis on fauna or nematodes or earthworm, for example, as well as microbial diversity analysis. All the data that came out from the field trials have been later on compared and analyzed in a more homogeneous and collective way. In this case, I want to show you just some example of the huge amount of results that we collected during the 3 years in all the 32 trials. And in particular for apple, I will show you some example of the agronomic performance and in particular related to yield. For strawberry, we will see something related to the effect on crown and vegetative development of the crop. And for tomato, we will see, for example, the plant biomass, the effect on plant biomass due to the bioinoculant application over the 3 years. Please go on, Stefano. Just giving a very, very quick idea of what we get from what we got from the single field trials, I can show in this table, for example, that all the different field trials had their own specific results. And from this table, we tried to make a very, very simple final conclusion, at least after 2 years of the 3 of the activities developed, implemented. But what I want to highlight is that, first of all, none of the field trials gave a negative effect on the plants compared to the control when the bioinoculants were applied. And this is one main result, so we can at least make on the table. But only some of the activities, only some of the field trials showed some very positive effect compared to control. That could be for the biopesticides or for fertilizer effect on the plants. If we want to go in the next slide to see some details and some examples, when all the data were put together and a comparative analysis have been carried out, as I said you before, we will see some example for apple on the yield. And from this combination of all the data, we can see, for example, that this kind of bioinoculants that is in this case categorized as MIC, combined with biostimulants that could be or compost or stronger or even vinassa, gave a significant effect on the yield compared to the control that is shown in this graph by the acronym UTC, so the last on the bottom of the graphs on your left side. But what I want to highlight is something we saw on all 3 crops studied in this project, that is other variables are playing a quite important role in the effect of the bioinoculants. In this case, we see on the right side of the slides that the management of the crop is very important in the final results on the effect of the binoculants. For example, we see that in general the yield is much higher where the management system is integrated system compared to organic one. And that is one variable I wanted to highlight to you. Please go on, Stefano. If we saw another example related to strawberry, in this case, we can look to crown and vegetative development. For this crop, these two variables or parameters for the crop development and production is quite important. We see that related to crown, it means the number of crowns that the crop could produce during their cycle life. We didn't see any kind of differences between the different binoculant applied and the control. But if we look the vegetative development, so the growing of the plant in general, we can observe that the binoculant made by Boveria brugnardi had a better effect on this parameter compared to other biocontrol agents as well as to the control. So even in this case, we can, however, mention that there are other variables that could play an important role to reduce probably the effect of these binoculants on the final data related to the crop development. That could be the location, so the pedoclimatic condition in which this kind of binoculant are applied, the kind of management, as we have seen already before for apple, but also the fact that the crop is cultivated in open field or greenhouse. So also these variables have to be taken in consideration related to the effect of binoculants. Please, Stefano, go on. However, related strawberry, I want to show you one very successful example of the different results we achieved along the projects. And in this case, we can see in the graphics on your left side of the slide where in two trials, the binoculants showed a very nice reduction of the disease severity and incidence on the main pathogens responsible for crown and root damaging, that in this case is Rhizoctonia solani for strawberry. This result confirms that the efficacy and efficacy of the microbial agents could have a concrete effect in this condition where it was applied. Of course, I can tell you that the binoculant that gave the best results was this co-inocula made of a combination of two fungi, Fusarium oxysporum and Trichoderma asperellum. And the result was also confirmed by the fact that the treatment of this binoculant on strawberry have also a good effect on the recruitment of mycorrhiza fungi in the root systems. And furthermore, we can highlight the fact that we find a positive correlation between the application of these binoculants with a higher percentage of yield compared to the control, as you can see in the lower part of the graphs. Please, Stefano. Going to tomato, I want to show you another example of the comparative analysis made combining all the trials implemented along the project by the several partners on tomato. In this case, we try to observe as a parameter the plant biomass. That was the more, let's say, common parameters analyzed and assessed along the different trials. In this case, we can see that there are two bioinoculants, in particular Mycosat and the mycorrhiza combined to biofactor, that showed a significant difference compared to the control, as well as we can see also for the mycorrhiza together with the fungi together with the bacteria Penibacillium polymixa, but but this last did not show an effect alone. So also in this case, we can highlight the fact that several variables can play a role to give an effect on the plants after the application of a bioinoculant. Please go over, Stefano. But just to tell you about another success story that we also found in the experimentation carried out in Italy at the University of Turin, we can see on these slides, for example, that showed you the results related to the biopesticide effect of the same kind of bioinoculant, in this case, as we have seen before for strawberry. So the combination of Fusarium oxysporum and Trichoderma asperellum compared to the control. In this case, we see that for both incidence and severity of the main pathogens observed on this crop, that was a combination of Rhizoctonia and Fusarium, we see that this kind of binocula gave a very nice effect on the pathogens compared to the control in field condition. And we can see that also the average yield per plant is in this case was not affected by the production. So we had the same kind of yield production along the different treatments applied. It means that the good biopesticide effect did not give a bad results on the production. And it means that it could be a promising, let's say, bioinoculants for the purpose of as a biopesticides in tomato as well as on strawberry. Please go on, Stefano. So arriving to the conclusion, we can say in general that the application of bioinoculants did not show very strong effect on the plant production or on the plant parameters related to the development of the plant on the three case study crops we analyzed, so apple, strawberry, and tomato. But the results showed that we had no adverse effect on the plant growth and productivity. We realized that there are many variables that play probably a very crucial role in the manifestation of the effect of these bioinoculants. And this could be the different soil climatic condition that we have seen through the trial carried out in different countries, the management systems, I mean integrated or organic cropping systems, the same kind of application of the crops or implementation of the crops in open field or in greenhouse, but even very important is the soil biodiversity that could be present in the different fields to optimize in general the bioinoculants application. We also saw that the bioinoculants could be very affected by an high mineral content, like phosphorus, more than probably nitrogen or potassiums. So we saw that we saw lower bioinoculant activity on the plants when high minerals was present. It means that it is important to monitor the soil quality also for the mineral content when we want to apply binoculars. As I already mentioned, probably the repeated application over the time could be also useful to study further. But just to highlight another important point is that when we applied bioinoculant and we reduced the chemical inputs, and in particular we reduced the fertilization of quite a big amount. It means around 30 or even 50% respect to the common practice of the farm. The application of bioinoculant, the agronomic performance, didn't change. It means that bioinoculant could be effective in the facilitation of the plants to collect the nutrients that they require by the soil. Finally, I can say that in general, the application of bioinoculant can probably improve, apart from what was seen on the plant, quite strongly the soil quality. The above mentioned points can let us to arrive to this kind of result, as well as all the several other analyses that have been implemented in the project. We have no time now to go deeply in this point because it will require a very important section related to the ecosystem service that they could, let's say, highlight in the soil. Please go on, Stefano. I want just to finish with some take-home messages. We can say that the different experience, the big experience we had along the time in these projects and with all the different field activities implemented, is not possible to say that one bioproduct can be suitable or effective in all situations. We can also say that the microbial we selected might not be necessarily find the condition to establish and proliferate in all pedoclimatic conditions, because probably the effect of native community has a very important role, and we have to take that in very nice consideration. The success story, in fact, that I also showed you today is that sometimes the superiority of native soil microorganisms in supporting plant growth and soil-borne pathogens control could be a very, very key point. In fact, the most significant results that I also showed you on tomato and strawberry related to the biocontrol effect obtained applying some bioinoculants were in the case in which the specific bioinoculants, in this case microorganisms applied, were selected directly in the soil of the same area in which they were applied later on. So the result of the antagonist effect on soil pathogens were very positive in this case. And with this, I think that I arrived to the end, but I want to give you one last information related to the fact that somebody said before that also the cost of the application could be an issue. I wanted to tell you that in EXCALIBUR also this aspect was analyzed, and I show you here one example related to apple and related to the costs that could be taken related to Italy, for example, but also for the other country involved in the project have been analyzed, of course. And in this case, we say a crop production cost in the whole cropping systems was taken in consideration. So for a direct cost, extreme direct cost, opportunity cost, and depreciation, and so on, as you can see listed in this table. But comparing the typical, that means the common cost of a typical farm in the common condition, compared to the case 1 and case 2, where there a reduction of fertilizer use of at least 50%, but with addition of the cost of bioinoculants in the case 1, or only with the addition of the bioinoculant cost in the case 2, gave at the end one very, very low impact on the production cost on apple in the case of in Italy condition, but probably the same even in the other country. So concluding that the cost of bioinoculant application is not affecting very much the cost of the production of the crops. And with this, I concluded.
Thank you. Thank you, Stefano. Good morning, everyone. Okay, I want to talk about the tools, the devices that we have developed for boosting the application of this bioinoculant in soil, but also for supporting the optimization and the application in the field of this product, and on the same time to effectively monitor the soil quality, because as we saw in the previous two presentation, it's too much important that we don't ignore the effect of soil microbial diversity, in particular soil native microbial diversity. And we know that the inoculation in the soil of a bioinoculant may affect this native microbial population, but the effect can depend from several variable because the soil ecosystem is too much complex, and chemical, physical, but also the pedoclimatic conditions can affect the establishment of this bioinoculant in soil, and can overall affect its native microbial population. We are also aware that changes occurring to the soil microbial structure may affect the overall soil health status, impacting, of course, crop productivity, quality, and human health. So, in this scenario, we dedicated too much effort in analyzing soil quality, generally speaking, and soil microbial diversity, going also in a deeper detail and applying, how to say, a multidisciplinary approach in this project. But we dedicated also effort and time in developing tool probe that allow to monitor the persistence and fate of this bioinoculant in soil once they have been applied, to see if they persist. They effectively find a good condition to establish before to say that a bioinoculant doesn't work. We need also to see if effectively this bioinoculant find the good condition to establish. And the tool that we have developed to monitor the fate and the persistence have this scope, so have these purposes. On the same time, this kind of tool can support the manufacturers in optimize the formulation of this bioinoculant, and can support also the farmer in finding the best strategy in terms of dose and application, also in terms of timing of application. This is also this can be also an instrument, a tool that can support the registration, because the field application of such product require their registration, of course, but require also such analytics methods that make possible to trace their destiny in the environment and prove their medium and long-term effectiveness. Lastly, but not less important, this kind of tool is also useful to avoid the fraud in the formulation. So to trace and to identify any eventual fraud in the labeling of this formulation. Please, Stefano, go on. Okay. So we have developed several tools based on the DNA. But in particular, we have developed a very innovative molecular tool for tracking microbial inoculant in soil. And we have selected the Bacillus subtilis as a microorganism on which we have developed this tool, because Bacillus subtilis is widely included in several formulates that are applied in soil as biofertilizer or not only as sometimes also as biopesticide. So we have selected this Bacillus subtilis as model strain, on which we have selected a particular probe, names aptamer. And we have also an Italian and European patent at the moment on this single-strand DNA sequence that we have used to develop this tool for monitoring and for tracking the presence of Bacillus subtilis in soils once applied to the field. And the monitoring and tracking of this bioinoculant in soil, again, is key to optimize both the bioinoculant application, but also to ensure the right amount of beneficial bacteria for maximum plant growth and protection. Please, Stefano.
Hello, Loredana. Here's Pablo from EUFRAS.
Yes.
It would really be a pity to stop here. Time is more or less up, but
Okay.
I propose you go on, because it's really interesting what you're telling us here. And
yes, I will very brief.
No,
yes.
no, I think you should go on and just to inform all the listeners, that you will need another 10 minutes, and it would be really nice if you can stay for these extra 10 minutes, and maybe if you then have another 5 minutes, by estimation, we need another 15 minutes to complete today, but it's really worth it. Thanks,
Pablo. Thank you very much. Okay, we have selected the aptamers technologies because this probe is very similar to antibodies, but show a lot of pros compared to the antibodies. And we have transferred, please Stefano, go on. We have transferred on a quartz crystal microbalance. We have immobilized this aptamer in order to develop please, Stefano, to develop a portable device to be used directly in the field without any necessity to go in the laboratory and to use a classical and traditional method to trace the persistence of this bioinoculant in soil. And this portable system is very rapid, precise, and offer also a low-costing monitoring on the field of the bacterial concentration. The second innovation is related to a model that we have developed for monitor soil quality. It's the first attempt in EXCALIBUR that we combine both physical chemical parameters with such biological parameters, because we know that the role of soil derived from its multifunctionality, and it's not just a matter to monitor one features, but the soil processes are too much complex. And please, Stefano. We were also thinking that maybe it was useful to provide to the farmer, but not only to technicians, advisors, and so on, to the end users, a web interface to calculate the soil quality index of their field trial, of the situation that they have. And this is reasons why selecting, as I said before, certain physical chemical parameters, parameter and biological parameters, we have developed these decision supporting systems for soil quality index analysis, but we have also developed this web, please, Stefano, a web page interface that you can see now in this slide, and that can be used by everyone to calculate the soil quality index. And this tool provides a QR code with a different color, and the color range show if your soil's worse or is in a good health. So, in conclusion, these are just two tools of the several tools that we have developed in EXCALIBUR. And despite the challenges posed by the soil complex matrix, we think that the effort put in place for developing method for traceability of our bioinoculant for monitoring the soil quality index are crucial steps toward a better understanding of ecological systems and for a correct adoption of practices involving the use of those microbial-based products. Thanks for your attention.
Yeah, and thank you to you, Loredana, but also to Maria, Grazia, and Stefano for these interesting presentations you gave us. Yeah, I think it's really what we advisors are looking for. Yeah, results from research. So when farmers or gardeners ask the advisors, yeah, is there anything reliable information on it? Yeah, so that with the Mentimeter survey, Stefano, you got exactly this what I think is the case. Yeah, we have not so much information on this rather new field of bioinoculants and soil biodiversity and effects on fertility, and is it really effective? Yeah, or is it only homeopathy for the soil, and does it provide extra costs? This will be the things the advisor really should know when a farmer confronts him with, what do you think about this or that bioinoculant? So this research you are doing, and also the tools now you were presenting in the end, I think can really be helpful. Yes.
Yeah, I think we got some good points, good results. Okay, we in our experience, as Maria Grazia showed, the costs of this kind of products is more or less comparable with the traditional, let's say, approaches and management. And so this should not be the main issue. The point is that we also succeed in many cases to reduce chemical inputs and getting the same results in terms of performance, and that's another good point. But of course, farmers need to observe something with their eyes, of course. And when you adopt this kind of products and you don't see any major or visible result in the field, sometimes they are not that happy. So they think that, in our experience, that happens. So they say, "Oh, why should I change my habits or my current practices for another product, another approach, which is, maybe good for the environment, but doesn't change that much for me, for my sustainability, and etc." So that is a matter. From the research point of view, of course, we really have to observe, for example, that the impact of these products may be really nice in terms of soil biodiversity promotion and soil health enhancement, etc. But from the farmer perspective, this is not always the main point. If they don't observe any increase in terms of yields or such kind of things. So
yeah, that was really good, Maria, that you also included the calculation, the cost calculation. I think this is what farmers, so say now, Stefano, are interested in. What do I get out of it if I change my practice? But we all together, we have the task of reducing pesticide application, and this, at least you have the proof here, that it can work with bioinoculants. Maria.
Yes, one result, however, that was achieved in some of the field trials showed, in fact, that if we can reduce some inputs, chemical inputs, like to reduce some fertilizer application, we can have, however, a concrete effect for the farmer as well, even if the application of bioinoculants doesn't mean increase the production, for example. But on one side, that could be an effect, concrete effect, to reduce some chemical application like fertilizer, or to reduce some, let's say, pesticides, to make some pathogens control in other cases. So these are concrete effects that for sure farmers are interested in. But I can say that farmers are starting, in general, at least in our condition, but probably in the rest of Europe as well, are starting to be a bit more aware of what could the soil biodiversity gave to the field productions. Because in a scenario where the chemical inputs are over less allowed, and there is a very big push to have less, let's say, tools availability in the meaning of pesticides, for example, or others like that, the possibility to have an help by microbials, by a higher amount of, let's say, organic matter into the soil and so on, are also some important aspects that the farmers are starting to look for.
Mm-hmm. And you showed also the graph of the interest and the market growing. This shows that the interest from farmers' side in these biological alternatives to chemical products, fertilizers and pesticides is rising. And I also agree with you that farmers, especially the leading farmers, they are dealing more and more with the alternatives and their soil. They more and they started to be aware really of that. It's important to have a good soil fertility to also to resist the climate change effects and so on. Let's say. Okay. Yeah, I thought you have been if you have been watching the chat, it is you can see that Stefano already answered some of the questions. I think you can read there. Marlene and also Leonid had questions and they were answered. Okay.
Yeah, but
Then maybe
the main point, I read some questions relating to so just to summarize in a unique answer. So yeah, our observation confirms that the best performance of the bioinoculants occur when the strains used for the to make the binocular were selected from that environment. So local derived products are more effective because they are likely more adapted for that kind of an environment and more competitive to survive longer in that specific environment. So that's exactly one of the main key points. So the persistence, the ability of these products to persist actively in the soil guarantee a better performance. So we can work at production level in order to provide a better formulation, in order to protect or made a formulation more stable over time, in order to being used in different environments more efficiently. Or another point is to better understand what's going on in order of biodiversity interactions, because we had some contrasting results with the same inoculants in different soils, the same crop, of course. So comparing soils where the inoculant was successful and where it wasn't, it's possible to find specific groups or drivers that are related to maybe they are likely promoting and guaranteeing a better success of the bioinoculant. So what we are actually doing is trying to understand which is the role of soil biodiversity, which are the actors that help these inoculants to be. And of course, another question I saw that it's related to the timing. So yeah, this is a research and innovation project. We did observations in the field during, over 3 years, which is not a super short period, but it's not a medium long term. So of course, these are just indications about which the research direction should be, but it's nothing definitive. But so yeah, about the question of if we need more time to have a wider vision of the effects of these products in the soil. Yeah, that's correct. This is just what we did in our time frame.
Okay.
Yeah, I don't know if there are other questions.
Maybe we can allow one more question, and then we would come to an end. Just speak up if you.
Yeah, because one quick comment is that these results may be useful for the farmers, of course, but also for the producers, because when manufacturers want to put a product on the market and they want to produce and prepare something effective, they are of course interested in knowing which are the main bottlenecks for the commercialization of the product, and which may be the regulation related to this. And so we did a lot of work in order to support also the producers for that. So the farmers, of course, were the main target of the project, but also for the producers and regulatory bodies that are expected to check for the safety of these products. And that's a lot of work to do. Yeah.
Yes. We got a good impression of the scale of your work and also I learned a lot, so it's very interesting, I think, for everybody in the chat. Now you'll see, for example, from Leonid from Ukraine, he's wishing you thoroughly success. And also from my side, I would also wish you success with finishing your interesting project Excalibur, and also if you go on with this kind of research, I think it's an interesting field for of research, and also with quite a meaning future to, especially what you said, to reduce chemicals. It can be really a solution. And you, again, finally to come again to the Menti survey, we are not so afraid of bio products, that we know that do no harm to humans and to environment. So this is, I think, the great plus, the great advantage of these products. Yeah, Stefano, Loredana, and Maria Grazia, thanks a lot. Thanks to all of you for joining us today in this EUFRAS coffee break. We are going to publish this on the website, and you are going also to find the contacts of Stefano, Loredana, and Maria Grazia if you have any further questions. Goodbye.